So let's look at Ostroff's Winter 18 number 2, which was this wedge. So we have a wedge, a part of a circle, and you want it to be a fence. So the idea is you have $3,500. Okay, so you have $3,500 and you want to make this fence, and that's in the shape of a a wedge, part of a circle. And the outside of the fence costs $5 per foot, but this little part here is only $2 per foot. So this little part here, because it's inside, is a little bit cheaper, I guess. $2 per foot, but all the way around is $5 per foot. Both the radiuses here and the part of the circle are $5 a foot. So the whole perimeter on the outside is $5 per foot. Okay, and then we want to have the biggest possible area. So what dimensions, what radius here, and what angle theta. So what angle theta gives us the biggest area possible. If we have too big a theta, we're going to have a small radius. If we have too big a radius, we have a small theta, so we want to balance those to give us the biggest area possible, given that we got to have a fence here for $2 a foot, and then fence the entire 2 radiuses and that length of the circle. Okay, so we want the area, and I worked this out in a video, and I can work it out again. It's real easy. So the area of the wedge divided by the angle of the wedge is the same thing as the area of the full circle, which is pi r squared, divided by the angle of a full circle, which is 2 pi r. And again, this only works in thetas and radians. So, sorry, not 2 pi, the area. The angle of a full circle is 2 pi. And so the smaller area of the wedge, the part of the circle, is to the theta of the part of the circle is to the full area of a circle divided by the full angle of a circle. So the pi's cancel. We have a half r squared, put the theta over there. So the area is 1/2 r squared theta. We want that to be as big as possible. That's the trick. Okay? Now, typically that means that we're going to want to write this as a parabola, and then if we find the vertex of the parabola, it'll be as big as possible. So we want it to look like, something like this, and if we find this point, the vertex, which is at negative b over 2a, that's the point at which the area is the biggest as big as possible. The problem is this is not a parabola right now. We have r squared changing and theta changing, so we need to get rid of one of those. Doesn't really matter which one. If we know one, we can figure out the other one, but we want to get rid of one of them. Probably the best thing to do is get rid of theta, so we got to use some other equations then to get rid of theta. So we just have r's to make it look like a parabola. Okay, so what do we know? We can look at our picture here and we say, okay, the total cost is $3,500. Okay, so the total cost, the total perimeter, the perimeter of our wedge is r, a radius, plus r, right, the sides, plus this thing here, and we said before that the length of an arc is r times theta as long as theta is in radians. So the perimeter is r plus r theta, the length of the arc, which of course is 2r plus r theta. And then this one here, the length of that arc is, the r is half of it, because they said it's exactly halfway. So it's just, its radius is r over 2 theta. So that little part there is r over 2 theta. Oh, and the perimeter cost, so what is the total cost here? The perimeter, each one of these feet costs $5. So the cost for the perimeter is 2r plus r theta, that's the number of feet, times $5 per foot. Okay, so times $5. That's the cost of the outside. Now let's look at this little wedge here, that little wedge there. The length is r over 2 theta, and so its cost is r over 2 theta times, it's only $2, so times 2. let's see, let's multiply these out. So that's 10r plus 5r theta, and this one is just the 2's cancel, so it's just r theta. So the total cost then, we just add those up. Total cost is 10r plus 5r theta, that's for the perimeter, plus this little part here, that little circle we just worked out, plus r theta. So that's equal to 10r plus 5r theta plus r theta plus 6r theta. And we know that that's equal to 3,500. That's what we have. So 3,500. And I think we got to always check units. I think everything is in feet. They didn't try to fool us. Everything's in feet. We know our angles, we're going to do radians. And so our cost is in dollars. So our units will be good. It'll make sense when we get it. Okay, so now we have an equation with a theta in it. So what we got to do here is solve for theta, plug it into this equation, and then we have all r's, and then this will look like a parabola, and we can figure out the vertex of the parabola to find out the maximum area. So let's do that. So solving for theta here, we have, let's put this on this side, 6r theta is equal to 3,500 minus 10r. Right, put the 10r over here, and then just writing it with the theta first. Or divide everything by 6r. Theta is 3,500 minus 10r divided by 6r. That's kind of complicated. It's looking kind of messy here. Hopefully it's not so bad. Okay, now we can take that and plug it back in here. So I'm going to need some room. So our area is 1/2 r squared times all this stuff, times 3,500 minus 10r divided by 6r. Okay, because that's theta, right? So from down here, theta is this complicated thing. We plug it into here. Well, what's nice here is the r's cancel. This r cancels one of those. And then we can just put this, that's 2 times 6, 12 on the bottom. So our area is equal to, we have an r in the top left, so it'd be 3,500 minus 10r. Actually, let me multiply all this by r, because we have that r in the top. Might as well do that in one step. So the r in the top multiplies out to 3,500r minus 10r squared divided by 12, because 2 times 6 in the bottom is 12. Well, let's divide that out. Probably it's not pretty. Let me see. What's 3,500 divided by 12? 291.6666. So 291 and 2/3. Yeah, that's good enough. So finally, our area is this 12 divided by 3,500 is 291. Let's just do that. So 291.66 forever. Make that into 7 r. Wait, don't put a line over it if it's a 7. That means we already rounded off. Minus 10 divided by 12. That's 5/6. I might as well decimalize that. 5 divided by 6 is 0.83333 forever. So 0.833 forever r squared, because that's an r squared. So minus 10/12. Okay, so that's our parabola. Now, the smallest area possible is easy. Have r equals 0, right? So that's easy. Have r equals 0. Well, we want the biggest possible area. So what r gives us the biggest possible area? So if we were to graph this, this thing here, we would see that it looks again like, because it opens down, right? Because the r squared term is negative. And let's write it the way we normally do with the r squared thing first. So negative 0.833 r squared plus 291.667. We know it opens down, so it does look like a parabola. We want to find the vertex, which we know is at negative b over 2a. So r is negative b over 2a is where it's going to be at the peak. So negative b is, forgot my r there. B is that. So that's negative 291.667 divided by 2 times A is negative 0.833. Okay, so we plug those into the calculator. So 291, so let's see. 291.667 divided by 2 divided by 0.83333 equals, wow, it's practically exactly 175. So the radius is 175 feet. That will give us the biggest area. So what is theta then? Because with our, oh, actually we don't need to know. So the area, when the area is 175, get the biggest area. They want to know what the biggest area is, so we got to plug that back into here. Okay, so now the area is negative 0.833 times 175 squared plus 291.667 times 175. So multiply all that stuff out. So 175 squared times 0.833 equals, I get, that's negative 25510.625, that's a lot of decimal places, plus this thing here, hopefully that's bigger, cancels out that big negative, 291.667 times 175. Okay, it's bigger, so this is making sense. So that's 25,000, this one's 51,000, and 41.725. So subtract those. 0.625, and I get about 25,531, close enough, rounded off. So 25,531. Let's see, we were dealing with feet here. That's the only unit we have, and this is area, so it's feet squared. Square feet, feet squared. So that many square feet, which is about what they got to. So, you know, within rounding errors, depending on how many decimal places. Looks like they kept the fractions the whole way, so they got 520 instead of 530, but yeah, close enough. Okay, so that's how you do this one. A lot of different steps, a lot of different parts to it, but hopefully it's not too bad. You just have to be really careful. They use this other way to directly define the area. I don't know. I think this is easiest. Find negative b over 2a, find r, and then you plug r back in there, you get back into the formula for the area. They kind of skipped that step and just found the minimum. I don't know. This is easier. So, okay. Hope that makes sense. Thanks for listening. Bye.